Motion control is a broad term used to describe an open-loop or closed-loop electromechanical system wherein things are moving. Such a system typically includes a motor, mechanical parts that move, and in many cases feedback sensors. Examples are automatic assembly machines, industrial robots, and numerical control machines. A servo mechanism is the traditional term applied to describe a closed-loop electromechanical control system that directs the precise movement of a physical object, such as a radar antenna or robot arm. Typically, either the output position or the output velocity or both are controlled. Servos can be used to generate linear or circular motion depending on their type. The makeup of a typical servo includes a DC motor, a gear train, a potentiometer, an integrated circuit, IC, and an output shaft. The desired servo position is input and comes in as a coded signal to the IC. The IC directs the motor to go, driving the motor's energy through gears that set the speed and desired direction of movement, until the signal from the potentiometer provides feedback that the desired position is reached and the IC stops the motor. Position is input and comes in as a coded signal to the IC. The IC directs the motor to go, driving the motor's energy through gears that set the speed and desired direction movement. The signal from the potentiometer provides feedback that the desired position is reached and the IC stops the motor. An example of a servo mechanism is the positioning system of a radar antenna. In this case, the control variable is the antenna position. The antenna is rotated with an electric motor connected to the controller, located some distance away. The user selects a direction and the controller directs the antenna to rotate to a specific position. The block diagram is shown to help identify the control components and to reinforce the principle. Numerical control, NC, is the type of digital control used on machine tools such as lathes and milling machines. These machines can automatically cut and shape the workpiece without a human operator. Each machine has its own set of axes or parameters that must be controlled. The workpiece that is being formed is fastened to a movable table. The table can be moved with electric motors in 3 directions, X, Y, and Z. The cutting tool speed is automatically controlled as well. To make a part, the table moves the workpiece past the cutting tool at a specified velocity and cutting depth. In this example, 4 parameters, X, Y, Z, and RPM, are continuously and independently controlled by the controller. The controller takes as its input a series of numbers that completely describe how the part is to be made. These numbers include the physical dimensions and such details as cutting speeds and feed rates. NC machines have been used since the 1960s, and certain standards that are unique to the application have evolved. Traditionally, data from the part drawing were entered manually into a computer program. This program converted the input data into a series of numbers and instructions that the NC controller could understand, and either stored them on a floppy disk or tape or sent the data directly to the machine tool. These data were read by the machine tool controller as the part was being made. With the advent of computer-aided design, CAD, the job of manually programming the manufacturing instructions has been eliminated. Now it is possible for a special computer program called a post-processor to read the CAD-generated drawing and then produce the necessary instructions for the NC machine to make the part. The whole process from CAD to finished part is called computer-aided manufacturing, or CAM. One big advantage of this process is that one machine tool can efficiently make many different parts, one after the other. This system tends to reduce the need for a large parts inventory. If the input tape or software is available, any needed part can be made in a short period of time. This is one example of computer-integrated manufacturing, a whole new way of doing things in the manufacturing industry. CIM involves using a computer in every step of the manufacturing operation, from the customer order to ordering the raw materials, to machining the part, to routing it to its final destination.